So having finished our model, we now need to proceed with the analysis, and it is much simpler here in Prota. So you can go to loading. We already put all the loadings. Now in case you want to put wind load, you can put the cases here. But now this is a short structure of just 6 meter or 9, and in Uganda we may not consider that wind load. Okay?
Yeah.
Yeah, so in case you want to put any wind load, that's there. Partition load, sometimes you find a partition wall is passing on top of a slab, so you can also consider it here. And the rain loads and what, but we don't have them here. Temperature loads, even in places where you have drastic change in temperatures like in Europe, you should also put that option there. So let's just go to this load cases. We come to this load generator. Are you seeing it here?
Yes, I can.
We shall try to generate them automatically. Our factor for permanent load is 1.35, so we change it here. Yeah. This was 1.1. It is here, 1.35. Then for the UDL is 1.5. You can see it here.
Yes.
Yeah, we don't select much. We are most interested in the dead and live load. Okay? So you can say okay. And it will try to generate combinations for you of live and dead load. And even so you can say okay. If you want to review, you can review from here, but there's nothing much. You can do model check and check whether it is constructed very well, and also they will show you 00 errors. You close. If you want to design, say if you have designed, it will show you different colors from here. But now we haven't even done the design. That's why you see it is all gray. Okay.
Yeah.
Let's go to analysis. Okay. Building analysis. Now here we have to change the materials. We have to come here to edit materials. I remember which concrete size do we say we should use?
1620.
Yeah, so we shall say 1620 and we shall apply it to all members. And the grade we can use 500 or 460. No, that's no big deal, because still we always reach that size. Then the bars for columns, I think it's okay to have 12, 16 and 20. You should always try to limit having bigger sizes of bars, because the cost is also high. I can also apply it to all bar classes. So you can cross check the beams whether the bars are okay. 12, 16, 20, yeah. Then you come to foundation. You also change the concrete class 16 to 20. You can change the reinforcement also to 460. The bars you can also include T12, because sometimes our bases are small. You limit the bigger bar sizes. So most of our materials are now all. Then you can cross check the links. The links R8 is okay, R10, 9 we don't have, 10 is okay. You can unselect these ones. Excuse me, shortly. I have a call. So we're at the materials and
13.
yeah?
The 13.
No, 13 no. We don't need 13 as links. Links 8 or 10. Nothing much than that. The rings, the stirrups. So we can have 10 and 8. So after selecting all our materials, now we are good to go. The rod combinations, these ones were already generated, they are here, okay? Now we just, if you have wind load, you have to continue to this tab, but this project we didn't have wind load. It will be a topic for another day. So let's come to analysis. If you want to check whether your model is built very well, you come to building model check. You start, so it will check whether things are interconnected properly. If you have built your model very well, it will show you 00 errors. Then you can come to building analysis. We want to analyze columns, beams. We don't have any still member, so we can give it an option of reselecting in case the bar size is not okay. Then you can proceed to building what? Analysis. So yeah, it will perform the analysis internally automatically, and it will be able to design these members and provide bars. It will show you in case a member is fading, it will show you an X. If a member is passing, it will always be green. And since we had already selected this shading of design status, it will actually show us which members are heavily stressed, which members are lightly stressed, to guide you when you're detailing your structure members. So it is trying to perform the analysis. The calculator is working internally. So it is done with columns. You see it is shading them green. It means most of them are passing. So now it is on the beam reinforcement. Which it has also shaded green, but there are some red. So it's done.
Yes.
Say okay, close. You can close. No problem. This shows the analysis, but this doesn't give more sense. Let me just close it. So you see our model, most members are green, okay? Apart from the ring beams, You see the ring beams?
Yes, I can.
The ring beams are showing red. It means the size we provided may be insufficient, okay? You get
The depth of the beam.
the depth, so we can try making it 250. Yeah?
Yeah.
We can make it 250. Now this color, actually I use this coloring thing, but I think it makes sense. So we can go back to the plan. We are still on the roof ring beam level. We can select all the beams. We right click. We come to member, beam table. We change this depth from 200 to 250. Okay. After it is updated, we can reanalyze again. Okay. Yellow is showing you that you need to reanalyze again. So we can go back to our analysis, building analysis. We just reanalyze again. The columns were okay. I think I can just do beams. Building analysis. So or you can always go and change the bar diameter. When the section is failing, there are two things you can change. You can change the section size, or the section parameters, say the concrete class, or you can change the bar size. If it is a smaller bar which was there initially, you can increase the bar diameter. But so for this case, we opt to change the section size because I think it is the cheaper. Concrete is cheaper than reinforcement. Okay. So I think it's done. And close. So you realize that some ring beams are passing, it is only the cantilevers. Yeah?
Yeah.
But something I forgot to do, our 3D seemed like the ring beam was touching here. Let me cross check with the architectures. I've just remembered now. You realize that our this is the structure we're working on.
How long is
You realize our second floor and the ring beam level,
that one?
they seem to be touching these columns.
The ones that are not designed by.
So we can now because they'll get support from these columns. Okay?
We didn't put it.
But still, if you follow this analysis,
That's what
it means it still calls you to increase the depth. Okay? Yeah?
Yeah.
Yeah, if we follow what we had already built before, it still calls us to increase the depth.
Yeah, it's length.
So we can make it 300 and see, okay? Yeah, we can make it at 300. There's nothing we lose by making it go back. We repeat the same process.
How come that
Forgot about it. How come what?
that you remembered it and
I'm not the one.
Huh?
To have Mr. Alfred, you say.
So
Okay,
as updated,
0.7
we can continue. We can repeat the same process. We do the
0.76.
analysis, building analysis.
Which division?
It will do the beam. It's the beam giving us that
0.
time.
Point what?
0.7.
So it repeats. I think when we have it, if it fails this time round, we can decide to change the bar size. We can go inside and change the bar size. Okay?
One.
Yeah.
Hold on.
Let it
It is more than
iterate.
the center. It is divided. So you put in all that because the big part is in all that.
So this is checking the reinforcement. So close. So luckily enough now it is showing us green, yeah? So meaning we don't have any member fading in our structure, okay? Okay? Hello?
Yeah.
So we have, from this step we have to continue with checking the individual members for detailing to check how many bars are there. But as far as the analysis is done, or what is missing may be the foundation, we can go and insert the foundation. You come to this 0. You can select all your bases. You right click, you say insert pad footing, okay?
Yeah.
I still have challenge with the foundation design for Prota. That's why I normally transfer the loads from Prota and I analyze the bases separately in TEDs because it gives exaggerated depth. The check for punching is too high here. Yeah, you can see now it gives a base of 1.6 by 1.6 and depth 800. Now 800 is too much for this load. That's why I normally transfer the loads. In the next session I will show you how we transfer these loads from here and we take them to TEDs. Okay? The foundation design here in Prota is a bit conservative. So literally this can be our model designed, modeled and designed for, then we can check the results. In the following session, we shall try to find out how we can make a report from this analysis. Okay? Walungi. Hello? Hello? So, if you have any question, you can ask, but our session will stop here because we have managed to build the model and analyze it. The next step, we shall do the design and do the reporting. Eh?
Yeah.
Okay. Do you have any